Hi! In our previous video, we have shown you that we can visualize sound waves and also analyze their frequencies. Here, let us see how we can manipulate the sound waves. First, we will go back to our favorite musical instrument, the clarinet, and listen to these sounds. This is a descending F major scale. We can now see how the sound waveform changes with a cell phone. When we put all the waveforms from the F major scale together, this is what we see. There's a repeating pattern for each waveform, and the time it takes for it to repeat itself is called the period T. We can see that the period increases when we go down the scale. F, E, D, C, B flat, A, G, F. The frequency of the sound is the inverse of the period. So the fundamental frequency decreases when we descend the scale. That is, the lower notes have smaller frequencies. You may notice that F3 is 1 octave lower than F4, and the period is exactly 2 times, so the frequency is half. Another interesting observation is that the waveform shape changes with the different notes, which suggested that they have different harmonics. We can also use our cell phone to study the frequency spectra of the different notes. Indeed, the fundamental frequency decreases when we go down the scale. In addition, we can see big differences in intensities of the harmonics, in particular the even harmonics like the second, fourth, sixth ones. These changes are due to the construction of the instrument, which gives us a rich sound when we use the clarinet to play a song. Here, you may wonder whether it's possible to make the same note with different harmonics with the same instrument. Luckily, we have a very, very powerful instrument with us, the human voice. Human makes sounds by passing air through the vocal cord, and we can change the frequency of the sound by changing the shape of the vocal cord. That's why we can sing with different musical notes. In addition, we can make different pronunciation with our mouth. That's why we can make languages, so that we can communicate with each other. Let us see how we can change the shape of our mouth to make different vowels. If we have a tight space in our mouth, we form the vowel E. By opening up the mouth, we can make R and then U sound. We can now see how the sound waves looks like with different vowels. Because I'm singing the same musical note, all the waveforms has the same period, meaning that all the sounds has the same frequencies. But we can see that the waveforms looks very different for the different vowels. Here are all the frequency spectrum of the different vowels. The fundamental frequency is about 150 Hz, corresponding to the E flat note. What is interesting is the high harmonics, especially between 700 to 3000 Hz. We can see the E vowel is dominated by higher harmonics around 3000 Hz. A has a more even distribution of high harmonics. There's a dip in the 2000 Hz harmonics for R, which is even smaller for the vowel O, whereas the vowel U has the smallest contribution from high harmonics. Now that we know how to tune the harmonics, we can now put them together to do something more interesting. Listen to the soundtrack here. In particular, pay attention to the high frequency note and see how it changes. This is known as harmonic or overtone singing. The person is singing the same fundamental frequency, but he can tune his voice so that he can emphasize a certain overtone. That's why you can hear a much higher pitched note coming out from his voice. You may want to replay this video to see how the frequency changes while he's singing. You may also want to check out other videos on overtone singing. They are quite interesting. I hope this helps you to understand more about sound and harmonics. Thank you for watching. Bye bye.